Hi, this is George here from Circuit Specialists. Today we're going to be doing a demonstration and a evaluation of the CSI3003X5 power supply. This is a 0 to 30 volt, 0 to 3 amp regulated linear power supply available from Circuit Specialists that has some very impressive specs and a very reliable price range. It comes with the unit itself, a power cable for the AC connection, and a set of AC leads. Now this power supply is linear, so it does have a transformer in it, so it is a little bit weighty, but very compact for its size. It also has a cooling fan that only runs when it's necessary, so it isn't unnecessarily noisy. And so what I'd like to do today is just demonstrate the accuracy of the controls and the metering, and also show you how to operate the constant list. Okay, the first thing to notice is that since this is a 3 amp supply, I needed a load that I could power up to 3 amps. So I'm using a 1 ohm resistor here, a 1 ohm 10 watt resistor. So that should be fairly linear with the voltage. Should be able to read the voltage and current. The other thing I'm doing here is I've got an external voltmeter measuring the voltage at the terminals, and I've got an external ammeter measuring the current through my load. One thing to note on this particular supply is it does have multiple ways of connecting the output. So I've got some screw terminals here under this plate, as well as the banana jacks on the front. Now notice I've got a minus, a positive, and a ground. The ground is a chassis ground, so it's not connected anywhere internal to the supply other than to the third wire ground in the electrical cord. So this supply is completely isolated, which means it can be connected in series with other supplies with no detrimental effects. The other thing I have here is a Handtech DSO to look at the ripple and also any transients or how clean the power is coming out of this unit. So I've got my 1 ohm load connected in series with the ammeter and in parallel with my voltmeter. Handtech scope is connected across the load now. And notice I have some ambient noise, which is basically just noise pickup from the wire leads. I'm going to go ahead now and plug the load up to the power supply. So notice my ambient noise is still there. My meters are both reading 0, which are in accord with the supply here. I have a small offset once I connected my load, but notice that it is a offset effect. That's an effect of the load itself. So I'm going to go ahead and crank the voltage up slowly. Notice it's a 10-turn adjustment knob, so I have very fine control. I can go up in 1/10 of a volt steps very accurately. And notice my load current increases pretty much linearly with the output. So I'm going to set this to 1.0 volts. Notice I get 1.0 here, 0.88 here, which means my load resistor isn't quite exactly 1 ohm, because it's a 5% load, so that's to be expected. So I notice I got 1 volt here, 9/10 of an amp. If I crank it up to 1.1 volts, my amperage now is pretty much 1 amp. We'll go ahead and go up to 2 volts. 2 volts, I get 1.8, which is right in line with what I saw earlier. Notice my ripple has not increased, nor has my noise level. Go up to 3 amps, which is the maximum that I can draw of the supply. And notice I do get over 3 amps. If I continue to increase it, notice the meter protects itself by going into constant current mode. This way you cannot damage this power supply by connecting a short circuit or a load that's too great for its output. So I'm going to go ahead and crank it back down just to get back to the constant voltage mode, which is indicated by the CV letters on the display. One thing that happens quite often with these supplies is the current adjustment isn't very well documented. So I'm going to take a few minutes and show you how now to adjust the constant current feature. I'm going to go ahead and crank the voltage back down just so I don't make sparks when I do this. Go ahead to set the constant current feature. I'm going to go ahead and disconnect the load. Use just a shorted piece of wire to short the output. Notice it is in constant voltage mode. Once I short the output, it drops down to constant current mode at its maximum limit, which is 3.04 amps. This button right here changes it from constant voltage to constant current and enables the buttons to let me adjust it. So I'm going to go ahead and go up. Notice I can go all the way up. I previously adjusted this. So I'm going up all the way to 3 amps, which I can. I can go down as low as I want, all the way down to 0. And it increases in about 30 milliamp steps. So the lowest resolution I have in the supply is 20 or 30 milliamps. So I'm going to do now, since I've already have it adjusted with this knob, I can go ahead and disconnect the short. I'm going to plug my load back into it. And we'll see if the numbers correlate with the settings I have. So again, I'm reading 20 milliamps and I'm reading 20 milliamps of my current, 0 volts, which is about right. Obviously it's more than 0 volts to be able to get 20 milliamps. But the resolution of either of these meters isn't sufficient to show that. I'll go ahead and crank it up. So if I go up now to an amp, I should be able to get back into constant voltage mode, and I should be able to get the amp. And there I am. So now if I take my short back out, my load back out, and I put my short back in, I should not go over 1 amp. And I don't. So this shows the supply protects itself and is also capable of operating in constant current mode, which means I can feed a constant current to any particular load I have connected, all the way from a short circuit up to a load of whatever the Ohm's law tells me is possible. Notice the scope screen that my noise has not increased at all. So this supply is very clean, power is very clean. I'm going to go ahead and demonstrate that I can go all the way up to 30 volts. And notice I do have a tenth of a volt resolution. So it's going to take me a few turns to get there, but also very accurate, very precise adjustments. I can go up a tenth of a volt very easily. So I go all the way up, and I do end up at 31.5, which is above the 30 volt capability of the supply. So I have a little bit of leeway there. And of course I can go back down all the way to 0.